Well, hello everyone. This is the preview activity 1.2.1 video. Just going to make sure we go over this and everything makes sense. You should have already done this and turned this in by the time you're watching this video. If not, just go back and do it real quick. This exercise shouldn't be too difficult, but it's just making sure that we have some basics of understanding and interpreting these graphs correctly. Alright, so determine the values of g of -2, -1, 0, 1, and 2. Okay, what is that asking us to do? Well, this is a function, and it's asking us to evaluate the function given the graph. And so the value inside the parentheses is our x-coordinate. So in this case, the x-coordinate of -2 is there. And you see that the point on the graph is at height 0. The y value is 0. And so we have g of -2 is equal to 0. If we do the same thing at -1, we get this point right up here, which is at height 3. So g of -1 is 3. Now something interesting happens at g of 0. At g of 0, you can see that there's a little circle here. That means that that point has been removed. In fact, if you see the point is actually located right here. And so g of 0 is going to be equal to 1 because that's the value at that point. At g of 1, we can see that the circle's here, but the dot's there. So the dot's up here. So g of 1 is equal to 3. G of 2 is also interesting because if you look at g of 2, there's a circle. There's an open circle here, but there's no dot. And what that means is that there is no value of the function. The function is undefined. And so, some people can be lazy, right? Equals undefined. Really, it should be a sentence. G of 2 is undefined. And so that's the first part. If the function is not defined, explain what feature of the graph tells you this. I just said it in words. I'm not going to write it down. But because there's an open circle and you see that there's no point anywhere here, when you try to find the value at 2, there's just no point there to be found. For part B, for each of the values, -1, 0, and 2, complete the following sentence. As x gets closer and closer but not equal to a, g of x gets as close as we want to blank. And so what's happening here, let's look at -1. When the value is -1, we're saying what happens to this function as you get closer and closer to -1. And you can see that as you get closer and closer to -1, the value of the function gets closer and closer to 3. So I'm not going to write out the whole sentence, but when a equals -1, the blank is filled in by the value 3. At a is equal to 0, you can see that even though the point at 0 is equal to 1, as we get closer and closer but not equal to, we are approaching this value up here, which is going to be 4. So at a is equal to 0, we are approaching the value 4. At, what's the next one, 2, you can see as we get closer and closer to 2, we're approaching the value 1, but we're not equal to this, so we're not actually evaluating at this point where it's undefined. And so that is the big key for understanding this section and understanding these ideas of limits, is that you're approaching but not equal to. And so that value is equal to 1. Part C, as x gets closer and closer but not equal to, whoops, sorry, that was 2. Closer and closer but not equal to the value a equals 1, what happens? So you can see that if you approach from this side, it looks like it's approaching the value 3. If you approach from this side, it looks like it's approaching the value 2. And so the answer to this question, does the function get as close as we would like to a single value? The answer is no. And you can see that it's approaching one value from the left and a different value from the right. And so because of that, this does not approach a single value. It actually approaches two values. In fact, in reality, all we care is that it's either approaching a value or it's not approaching a value. In this case, it's not approaching a single value. And so the answer to this question is no, it does not approach a single value.